I'm hoping that you remember from the previous section when we were doing compound interest that it's possible to write the formula a little bit like this thing here. So the amount in an account is equal to the initial amount in the account, the principal, times, and then you remember that there was a 1 point something or other expression in here, and then up here there was another number. The number up here was the number of times that interest was added, and it was equal to, for example, if it were monthly compounding, it was 12 times however many years. The n was equal to 12. And to calculate what goes inside the brackets, you had to do the interest rate, whatever the interest rate was, as a decimal, divide it by however many times you compounded per year. If it's monthly, then n is equal to 12, and then add that to 1. So for example, if the interest rate were 12% and we had compounded monthly, we would have to do 1 plus 12, 0.12 rather, divided by 12 in here. And that would become 1.01, that whole thing. Now, that would be for a monthly compounding. If we had daily compounding, the n would be 365 instead. But it's not just that we could compound daily, we could compound every hour, in which case the n is going to be a lot larger, whatever 365 times 24 is. But we might not stop there either. We could continue, we could compound interest, we could add interest every minute, in which case the n gets even larger. That's however many minutes there are in a year. Or we could do it every second, calculate how many seconds there are in a year, and that would replace the n there and there. But it might not even stop there. We could have every millisecond, every microsecond, every nanosecond. We could be compounding interest. Now, I don't want to go too much into the details, the mathematical details behind this, but if we did that, if we kept on going so that we were adding interest in infinitely short periods of time, then what we would end up with would be that this equation up here, this equation up here would become this equation here. Right, there's the whole thing inside kind of gets replaced with the e, and we just have the interest rate, r as a decimal, and t as the number of years. And so this is a lot simpler than this expression here would be if we had a large value of n. And it's fairly easy to use that formula. So if you invested 2,000 francs and an annual interest of 5% for 10 years, it's very easy to use this formula to calculate how much will be in the account after 10 years. All we have to do is fill in the blanks. So the r in our example here is 5%, but write that as a decimal. Notice we've written 0.05 instead of 5%. The t in this case is 10 years, so we're going to have t equal to 10. And then when we plug those in, what we should get is this expression. Simplifying that a little bit gives us this. And if we do that on our calculator, you just use the e to the power of button on your TI-84. What we will get after that is 3,297 francs and 44 centimes. And that would be slightly more than the value you would get if you just compounded annually or quarterly. Basically because you're adding interest at an earlier stage. You're adding it after every millisecond, let's say.